Hey, this is Mr. Zuckerbrow, and this is Unit 1, Lesson 5A for 8th grade. And this lesson is going to be all about parallel lines, perpendicular lines, and angle relationships. So before we jump into lesson, we're going to complete this graphic organizer. It'd be a good idea to try to fill it out by yourself before you watch the video to see what you remember and what you don't remember. And then we'll go over it. So if you want to pause the video, you can. Otherwise, I'm going to jump right in. So parallel lines, the first thing we need to do is we need to define it in our own words. I don't want to get too technical. I want to stick with using words that we understand. I am using a different device here, so we're going to see how this goes. So parallel lines is the one that students normally remember. It is lines that, maybe this won't work today. Go back to the old method. I'll have to work on that, using that pad. Alright. So parallel lines are lines that never touch, that never intersect. So lines that never touch, they never intersect, they never meet, however you want to talk about it. The reason they never meet, the real definition of parallel lines is lines that are always the same distance apart. So if you have two lines and they're this far apart and they're always this far apart, then they're never going to touch. So if you have two lines and they look like this because they're going to get closer together, then eventually they're going to touch. In order to be parallel, they always have to be the exact same distance apart. They never touch. Draw it. Usually it looks something like that. That's not perfect, but pretty close. Can you think of any real-world examples of it? A popular example is streets. So most cities are laid out in like a grid view. So if you picture Manhattan, the avenues, the ones that run north and south, so like 2nd Avenue and 3rd Avenue, are parallel to each other. Obviously, it's not perfect with streets, but you get the idea. Maybe Amboy Road, and Highland Boulevard. They're pretty parallel. Obviously, they curve, but we'll go with it. Popular example I get every year is a ladder. Either the two long outside of the ladder, I don't even know the word, the support, or each rung of the ladder are parallel to each other, or even like train tracks, the two train tracks. Now, perpendicular lines, this is where students make mistakes. Perpendicular lines are not just any two lines that intersect. They're like, oh, it's the opposite of parallel. No. Perpendicular lines, and I'm going to type it, that might be easier. Perpendicular lines are lines that intersect and form right angles. I'm going to make that smaller, and we're good. Here we go. Lines that intersect and form right angles. So not any lines that intersect, only lines that intersect and form right angle. And when I draw a picture, that might help you visualize it. So they have to touch, and they have to form right angles. So there's two common diagrams. You'll see this one, where they completely cross, and in the middle you can see there's 4 right angles represented by that little box. Or they don't have to completely cross, and what I mean is they can be just like a T-shaped, where they still form right angles. So these lines, this one going here and this one going across, are perpendicular because there's a right angle, and these lines are perpendicular because there's a right angle. These two red lines are parallel because they will never touch. Okay, so before we get into this, really quickly, I just want to do a quick review on angles. I find that students have problems with angles because they don't have a good foundation. They can't even define what an angle is. So, thinking about it now as you watch this video, can you tell me what an angle is? I bet you can't. Not a great definition. So an angle occurs when two lines meet. So they meet at this point. This point is called the vertex. You'll hear us use that word a lot. That's a vertex. And usually we label it with like a letter. So this is like A. But that's a vertex. And when two lines meet at a vertex, they form an angle. The angle is the space in between the two lines. So you can see here that these two lines are kind of close together, so they make a small angle. Let me draw two lines that are not close together. So here's one line, and here's another one. So this is a much larger angle because look at all of this space in between the angles. That's what the angle is. It's the space between the two lines. So you have to look at where two lines meet, and then you draw like this little arc that I drew in red, and that's how you represent an angle. All right, let's jump in. So look at each picture and just write down some facts you know about triangles. This one actually came up in lesson 4, so you should remember it. So this is a triangle. We labeled the angles A, B, and C. And what do we know about the 3 interior angles of a triangle? Don't get thrown off by that word interior. Interior just means inside the shape. And we know that A plus B plus C, the 3 angles of a triangle, add up to 180. Alright, so now we look at this triangle on the right. And you can see that we extended the bottom side. So it goes a little further, and that actually created this angle right here that we call D. Not always, we just called it D. So we have the 3 interior angles. We have A, B, C. Those are the 3 interior angles. So what do you think we call angle D? Which I am trying to get, there we go. Angle D, because it is outside of the triangle and it is formed by extending one of the sides of the triangle. We actually call that an exterior angle. Hopefully you've seen that word before. So angle D is called an exterior angle. And now what conclusion can be made about angles B and D? Now there's a couple things. One, they're next to each other. In math there's a word for that. So angles that are next to each other, as I write it, maybe you'll think of it. Next to each other. And that word is adjacent. All that word means is next to each other. It has a more specific meaning in math, but I'm not going to get into it right now. So angles B and D are next to each other, but, and here's the important part, if you notice, together, if I draw the angle of B, they make a semicircle. They also form a straight line at the bottom. Angles that form a straight line or create this semicircle add up to 180 degrees. So what conclusion can be made about angles B and D? They add up to 180 degrees. There's actually a really good vocabulary word for that we're going to get into in a couple of slides. I'm going to hold it off there. Alright, so here's just a nice checklist of triangles. We know the sum of the interior angles is 180, and you can see that here. Here's the 3 angles, the green, the blue, and the red. And you can see that the measure of angle A plus the measure of angle B plus the measure of angle C equals 180. And now here, an exterior angle is formed when the side is extended outwards. So you can see right here, angle D is an exterior angle. The exterior angle is supplementary with the adjacent interior angle, meaning, and we just talked about this, that angle D and angle C add up to 180. Make sure you're filling this in your notes. Or, if I wanted to figure out angle D and I knew what angle C was, I can just do 180 minus C. And we'll practice with that in a few slides. There's also one more thing that you need to know, and it's known as the exterior angle theorem, but don't worry too much about that. There is another way to find this exterior angle, angle D. The exterior angle is equal to the sum of the 2 non-adjacent angles. Remember, adjacent means next to, so non-adjacent means not next to. So angle D, right here, I'm circling it in red, equals the sum of angle A and angle B. So if I know what angle A is, I know what angle B is, I just add them together and that gives me angle D. And that's true for any triangle. So an exterior angle is equal to the sum of the two angles that are not next to it. Alright, so here are 6 triangles, and you need to find all of the missing angles. In the first one you need to find x, in the second one there's 2 x's you need to find, in the third one there's an x and a y, and so forth. So you should pause it and try this on your own, and when you unpause it I'm going to go through them, so you should just watch, make sure you got it right, make sure you understand. So number 1, they give you 2 of the angles of a triangle, but not the third. I'm going to show you 2 ways to do this really quick. When you know 2 of the angles of the triangle and you're missing a third, the first thing you need to do is add up the 2 angles that you have. 70 plus 45 is 115. And then, since all of the angles add up to 180, I just do 180 minus 115, and I get 65. So x is 65 degrees. My justify at the bottom where it says justify, that's usually they're looking for words, I can write that the 3 angles of a triangle add up to 180. That's my justification. So the 3 angles of a triangle add up to 180. The other way that you could have done this is by writing an equation. And we kind of went into this in lesson 4 a little bit. We know that the 3 angles of a triangle add up to 180. So 45 plus 70 plus x equals 180. So you could have used that equation to find x. It's the same exact thing. Alright, let's take a look at number 2. So this one we only know one of the angles, but both of these angles are called x. So what does that tell us about both of them? Since they're using the same variable, that means they have to measure the same amount. So, again, I can do this in 2 ways. One is the procedural way, where you're just using arithmetic. So I know they all have to add up to 180. So 180 minus 110 is 70. So I know that these 2 angles together must add up to 70. And since they're the same, now this only works because we know they're the same, because they're both represented by the variable x, we can just divide 70 by 2 and get 35. So each of these angles is 35 degrees. The other way to do it would have been to write an equation. So 110 plus x equals 180. You're just adding up the 3 angles and setting them equal to 180, because we know that the 3 interior angles of a triangle have a sum of 180. Alright, number 3. And number 3 is a great question because you could do it in different ways. That's not the only reason it's a great question, but it's one of the reasons. So, it looks like we're looking for y, which is an interior angle, and x, which is an exterior angle. So, if I knew what x was, I could figure out y. If I knew what y was, I could figure out x. We can actually find either one of these first. The first thing I could do is I could completely ignore the x and just look at the triangle. So this would be very, very similar to number 1, where I'm just looking for a missing angle of a triangle that we know how to do. And then once I know y, I could figure out x, because x and y together add up to 180, because they form the semicircle, and the bottom of them forms a straight line. So once I know one of them, I could figure out the other one. I'm actually going to find x first, because I want to give you practice using the exterior angle theorem. Remember, an exterior angle, an angle that's outside of the triangle, equals the sum of the 2 angles that are not next to it. So x equals 62 plus 51. And that'll give me x. So 62 plus 51 is 113 degrees. So that's x. So now that we know x, we can figure out y. Let me switch colors. There we go. So remember we said that x and y together, since they form a semicircle and they form a straight line, they must equal 180. So 180 minus 113 is 67 degrees. And that's the answer. Now, you could have figured out y first. You could have done 62 plus 51 is 113. 180 minus 113 is 67. And then once you have 67, do the same thing to figure out x, because they equal 180. Alright, number 4 is always one that's a little trickier. But again, there's two ways to do it. I'll show you the way using the exterior angle first, and I'll show you the other way. So this 110 degrees is an exterior angle because it is outside of the triangle. Well, remember, an exterior angle equals the sum of the two angles that are not touching it. So 110 equals 90 plus x. So I can actually write that as an equation. The exterior angle equals the sum of the two angles that are not touching it. So now I just have to solve this equation by minusing 90 on both sides, and that gives me x equals 20. So that's one way to do it. So here's the other way you could find it. Since we know this exterior angle is 110, I can actually figure out this little angle right here that's right next to it. Because remember that an exterior angle and the angle next to it, let me switch colors so that you can see what I'm doing. There we go. The exterior angle and the angle next to it add up to 180. They're supplementary because they form a semicircle and the bottom of their angles form a straight line. So 180 minus 110 is 70. And then once I know 70, now that I know two of the angles, because this one is 90 because of that box, I can figure out the third angle of the triangle. Alright, number 5. This is similar. It doesn't matter which to figure out first. You can figure out y first or x first. I will say that most students find it easier to find x first. So the way you find it is remember that an exterior angle and the angle next to it, these two angles form a full semicircle, and you can tell it's a full semicircle because they form a straight line. The bottom of their angles, or in this case the top, form a straight line. That means they add up to 180. That means they are called supplementary angles. So 180 minus 120 is 60 degrees. And now once I know that this is 60, these two angles together add up to 130. 180 minus 130 will give me y, which is 50. I can check that. 70 plus 60 plus 50 is 180, so that's correct. Also, if you notice, the exterior angle is 120, and 50 plus 70 is 120, so that's another way to check your answer. We look at number 6. We have to find 3 missing angles, all exterior. So let me start with x. I notice that the angle next to it is 30. If I draw the angle lines, the 30-degree angle goes from there to there, and x goes from here all the way to there. So that looks like a full semicircle. How do I know it's a full semicircle? Because on the bottom of it, I have a perfectly straight line. So they must add up to 180. So x is 150, because 150 plus 30 is 180. I could do the same thing to figure out y. Let me switch colors. Full semicircle, straight line. 180 minus 85 is 95. And now there's 2 ways I can figure out z. Either I could figure out this missing angle first, because there's 3 angles of a triangle and they add up to 180, or I can use the exterior angle theorem, and I know that z, which is an exterior angle, adds up to the 2 interior angles that are not next to it. So 85 plus 30 is 115. Okay, so in your groups, well, we're going to do this together. List facts you know about the diagrams given. So one thing I notice right away is we have a 90-degree angle. So there's a lot of facts we can list. I'm only going to put the main ones here. So we have a 90-degree angle. And since it's a 90-degree angle, what does that tell us about these two lines, about AB and BC? What do we call lines that intersect and form a 90-degree angle? Hopefully you're thinking of the correct word. It is perpendicular. So AB and BC are perpendicular because when they touch, when they meet, they form a right angle. Now, how many angles do you see in this diagram? I see 3 angles. I see the big one, which is 90 degrees, and they drew the box. I see this one, A, that goes from A to B to D. From A to B to D. Let me draw it in purple. That angle right there, that's a second angle. And I also see a third angle. And that goes from D to B to C. So that would be right here. So there's 3 total angles in this picture. So hopefully you see that. And I notice that they form a right angle, which is 90 degrees, perpendicular. So these 2 angles, the purple angle and the blue angle, because the whole one is a right angle, they must add up to 90 degrees. So this is how we're going to write it. The purple angle, the angle symbol is this. And then since it goes from A to B to D, you have to write angle A, B, D. And now the blue angle is angle D, B, C. That's how you list angles. And now, when you add those 2 angles together, let me switch colors so it's not confusing. When you add those 2 angles together, it equals 90 degrees. Because the whole angle, ABC, is a right angle. That's going to be important because if I told you this purple angle was 20 degrees, then you could figure out the blue angle using this knowledge right here. The second fact, let's say that lines AB is perpendicular to lines BC. I'm using the symbols here just so you get used to seeing them. So to write a line, you write the 2 letters that make up the line with a little line segment on top of them. And this upside down capital T is the symbol for perpendicular. Alright, so now I look at this second diagram, and again I see some angles. I'm going to draw them in different colors. So WXZ is an angle right here. You can see me highlighting it with the pen. I'm going to draw that one in purple, so that goes from here to there. And I'm going to draw the other angle in blue. That would be ZXY, and that goes from here to here. And if you notice, what do they make? A semicircle. And just to make sure it's a perfect semicircle, the bottom is a straight line. So that's what I noticed. So angle, and I'm going to write it in color codes again. Angle WXZ, and the blue angle is angle ZXY. And when I add them together, it's going to equal 180 degrees. I notice that these angles make up a straight line. That's my cue that it's 180. These angles over here make up that perfect L-shaped. That's 90. So what other facts can we say? We can say that these 2 angles, so this angle and that angle, are supplementary. Supplementary is a word that means adds up to 180. It's angles that add up to 180. In the first diagram, since the angles add up to 90, we call them complementary. Those are 2 words that are easily mixed up because they look similar, and until you get super familiar with them, they're easy to mix up. For me, complementary comes first in the alphabet compared to supplementary, so for me this is the smaller one. I know that one of them is 90 and one of them is 180, so I remember that this one's smaller. I know another way you can remember. If you take a look at the letter C in complementary, and you draw a line down of it, the first 2 letters now look like 90. You see how I turned the C into a 9? Similarly in supplementary, I can turn the S into an 8 and then that could be like 180. That might not be for everyone. There's different ways, or you can just memorize them, but that works. Alright, so here's some angles. You can see that this angle, the space between them, is 145 degrees, and I can draw a little angle marker on it, like this. You can see it's a pretty big angle, whereas this is a 35 degree angle. The space in between these two lines is only 35 degrees. So I can draw that little angle. You can see it's a little tiny arc. I like drawing these arcs because it tells me how big or small the angles are. So we call this an obtuse angle because it's larger than 90 degrees. Notice I'm not writing anything, but you can feel free to take notes if this is things that you don't remember. At this point, anything I'm talking about, you've already learned at some point. So if you're sitting there and you don't remember it, and you think, I'll remember it this time, you might not. Because if you didn't remember it up to this point, maybe you won't. So it's probably a good idea to write down. So an angle that's larger than 90 degrees is obtuse. An angle that is less than 90 degrees is acute. Now these two angles are very specific. We made them the way we did for a reason. What will happen if I push these two angles together? So if I take this angle, and I take it, and I move it, and I push it over there. Does anyone see what's going to happen? So I'm going. Oh, I noticed something starting to happen. Take a look at that. What happened when I push those two angles together? I'm going to take out a blue pen now to show you. Or, yeah, that's fine. The bottom of the two angles matched up perfectly. This line matched up perfectly. They make a straight line. And look at this. Those angle markers I drew made a semicircle. What's 145 plus 35? 180 degrees. So angles that add up to 180 will make a straight line when pushed together, if you push them together in the right way, or they'll make up a semicircle. So these angles, again, are called supplementary angles because they're two angles that add up to 180 degrees. I can tell by looking at this diagram because I see a straight line and I see that semicircle. Those are my clues that these add up to 180. What do we call angles that add up to 180? We just talked about this. Supplementary angles. In what kind of diagrams will we see supplementary angles? So we will see them in straight lines. We will see them in semicircles. And where else have we seen that 180 degree number today? Triangles. The three angles of triangles are supplementary because they always add up to 180. So this is where we're going to need that. Now we need to find this missing angle. So here's a diagram. They tell you that this angle right here, I could do that a little better. That angle right there is 67 degrees, sure. We're not going to take it out and measure it exactly, but we'll go with it. How do we find this missing angle, the one next to it, x? This is where I need to notice, okay, these two angles, when I draw x, I'm going to use a red pen. When I draw x, and I connect it to what I already drew for the blue one, look at that, they make a semicircle. How do I know it's a perfect semicircle? Because sometimes they're not perfect, maybe it's not a full semicircle. I know because the bottom of it makes up a perfectly straight line. When you see this kind of diagram, where the two angles make up a straight line or a semicircle, that means they add up to 180. So to find the missing angle, 180 minus 67 is 113. That's a 1. 113. So these two angles are supplementary. Alright, here's another diagram. We need to find the missing angle. This time is a little different because there's three angles here. And at any point you need to pause this because you want to try it yourself, please go ahead and do so. So there's three angles here. And the reason I put this diagram here is because a lot of students get confused. They think that this angle and this angle, I'm going to draw them in red actually, that this one and this one together are 180 because the bottom of this 51 degree angle is here. the bottom of the 48-degree angle is here, and that sure does look like a straight line. But look what happens with the semicircle. The semicircle is missing a chunk out of it. So this is not a full semicircle. It only becomes full when you include that third angle. So these three angles together are supplementary. These three angles together add up to 180. So you can either write an equation like this one and then solve it, or you can add the 51 and 48 together and then subtract it from the 180. 51 plus 48 is 99, plus x equals 180, minus 99 on both sides, and it's 81 degrees. So that's the missing angle there. So notice, when you draw the semicircle, make sure you include every angle that's part of it. Alright, here's a mid-lesson assessment, and your groups answer the question. So which one is true? I would pause the video, see if you can figure this one out. Remember that complementary are angles that add up to 90 degrees, and you're looking for that like perfect L. Supplementary are angles that add up to 180, so you're looking for a straight line, or you're looking to draw the semicircle on it. Okay, so at this point, hopefully you pause the video and you have at least a guess. I'm going to go through each choice. So angle 1 and angle 2 are complementary. So here's angle 1. It goes from this line to this line. And you can see they already drew something there. So it looks like angle 1 is 90 degrees. And here's angle 2. So are angle 1 and 2 complementary? Remember that complementary means 90? No. Because angle 1 is 90 degrees on its own. Here's a separate question. Are angle 1 and 2 supplementary? Because look, they form a semicircle. Except, this is not a full semicircle. This is a good example of what I was talking about. Because if I draw the bottom of the semicircle, is that a straight line? No. So angle 1 and 2 don't have any special relationship. They're not complementary. They don't add up to 90. They're not supplementary. They don't add up to 180. All we can say about them is that they're next to each other. And the word for next to each other is adjacent. So choice A is wrong. Angle 5 and 3 are complementary. Let's see. Here's angle 5. Here's angle 3. Is there any information here that tells us that they add up to 90? No. Angle 5 and angle 3 actually do have a very special relationship that we have not learned yet, but we will. But there's nothing here that tells us they add up to 90. Could they? Maybe. We don't know. Angle 2 and 3 are supplementary. Well, here's 2, here's 3. That's clearly not a straight line. So no, they are not supplementary. In fact, they are complementary because they make up a perfect L together. So they are not supplementary to complementary, which brings us to choice 4, or D must be the answer. 4 and 5 are supplementary. So I can see that angle 5 goes from here to here. Angle 4 goes from here to here. Ooh, a nice semicircle where the bottom of those angles, the bottom of the semicircle, makes a perfectly straight line. They add up to 180, supplementary. Fill in the blanks. So see if you could pause it and do it on your own. So lines in a plane is a flat two-dimensional surface. Lines in a flat surface that never intersect are parallel. And we talked about that earlier. So in the diagram, which lines are parallel? Lines blank and blank are parallel. Well, the first one is CD. And I'm going to put the little line marker on top of it. And the second one is EF. So lines CD and EF are parallel because they will never touch. Lines that form a right angle are perpendicular. So lines blank and blank are perpendicular. I'm going to abbreviate it as perp. Are perpendicular to line segment AB. Here's AB. So which two lines are perpendicular to it? Well, you can see the hints. They drew these little 90-degree boxes. So lines CD and lines EF are perpendicular to AB. And you can see, because here's AB, here's CD, they make a right angle. Same thing with EF. Okay, so when two lines intersect, and here's a very, very important part, and if you remember, I said that angles 3 and 5 in that previous question have a special relationship. Here it is. When two lines intersect, they form two pairs of vertical angles. Vertical angles are across from each other and congruent. So angles that are across from each other are called vertical angles. And you want to get really good at identifying vertical angles. Let me give you an example. I'm going to draw a line. So here's one line, here's another. They intersect. Let me label these four angles, 1, 2, 3, and 4. Which angles are across from each other? Well, angle 1 and angle 3 are across from each other, so they're vertical angles. And also, 2 and 4 are vertical angles. So when lines intersect like this, they form these nice four angles. The ones that are across from each other are known as vertical angles. So 1 and 3, 2 and 4. And the reason that is important, and we said it right here, is because vertical angles are congruent. What does the word congruent mean? Congruent in math is a synonym of the word equal. Congruent means has the same measure. So I know two angles are congruent when I see this symbol. So the symbol for congruent, maybe you know it, maybe not. It's an equal symbol with a little squiggly line on top of it. That's the symbol for congruent. So in my example that I just did, I can say that angle 1 is congruent to angle 3. So don't get confused if you see that. If you want to write angle 1 is equal to angle 3, that's fine also. But this sign means congruent. So here's an example. We have intersecting lines. So line AB intersects with line CD, and it creates these four angles. And they want you to list two pairs of vertical angles. Remember, vertical angles are the ones that are directly across from each other. So if I look back at that multiple choice question, angles 3 and 5 were across from each other. And you can see how they kind of look like they're the same size, because they are. So back to this one. The vertical angles are angle 1 and, in this case, angle 2. You have to look at how it's numbered. So here's angle 1, and it's across from angle 2. And then the other pair is angle 3 and angle 4. I could draw that a little better. Angle 3 goes from here to here. Angle 4 goes from here to here. So angle 3 and angle 4. Now in the same diagram, name some pairs of supplementary angles. Remember that supplementary angles add up to 180. They form a straight line. They form a semicircle. So I'm looking at this diagram and I'm looking for straight lines, or I'm looking for semicircles. The first pair of supplementary angles that I see, angle 1 and angle 3. They form a semicircle. They form a straight line. So angles 1 and angle 3 are supplementary. Similarly, angle 1 and angle 4 form that nice semicircle and a different straight line. So they are also supplementary. So angle 1 and angle 4. And then I see that angle 3 and angle 2 form a semicircle and a straight line. So 3 and 2. And then also angle 2 and angle 4. Right down here form a semicircle and a straight line. Let's do some practice with this. So here's a diagram. Let me get the screen shade up so we only look at one question at a time. So here's this bottom angle, which I guess was angle 4, is 120 degrees. We need to find how much angle 1, 2, and 3 is. Now, I look at this diagram, and one of the other angles, I already know what it is without doing anything. I don't have to do any arithmetic, any work, any math. If I know that this bottom angle, angle 4, is 120, which other angle do I know? I also know angle 2, because angle 2 and angle 4 are vertical angles, and vertical angles are congruent. You need to start hearing the vocabulary, you need to start using it yourself, and you need to start understanding how to make sentences with that vocabulary. Angle 2 and angle 4 are across from each other, so they're called vertical angles. We know that vertical angles are equal. So this one right here is also 120 degrees. Sorry for the sloppiness. So now I need to figure out either angle 1 or angle 3. Well, I noticed that this one they gave us goes from here to here, and angle 1 goes from here to there. Oh, we have a semicircle. I have this nice straight line. What do we know about angles that make up a semicircle or a straight line? They are called supplementary angles. And supplementary angles add up to 180. So 180 minus 120 is 60 degrees. And since angle 1 is 60 degrees, angle 3 has to also be 60 degrees because they are vertical angles. They're across from each other. All right, let's take a look at this next question. So it tells you that angle 4 is equal to 132. So on the diagram, I want to add that on there. It's helpful to write it on. And now I need to figure out all the other ones. If you want to pause it and try it, great idea. Otherwise, I'm going to go through it right now. So angle 4 and angle 1 are across from each other. They are vertical angles. So angle 1 is also 132 degrees. And then I noticed that angle 1 and angle 2 form a full semicircle, a straight line. So angle 1 and angle 2 must be supplementary. That means they add up to 180, and 180 minus 132 is 48 degrees. And since angle 2 is 48 degrees, angle 3 is also 48 degrees. How do I know that? Because they are across from each other. They are called vertical angles. Vertical angles are equal. Okay. Moving on, here's 2 more questions. Pause it, try these on your own, and then unpause it and I'll go through them. So in number 1, they give you that this first angle is 60 degrees and I need to find all the other ones. You don't have to go in order. For me, the easiest one to find is angle 3. When you see this, M angle sine 3, that just means the measure of angle 3, the measure of angle 2. So the measure of angle 3 is 60 degrees, since 1 and 3 are vertical angles. And then I just need to figure out either 2 or 4. I'll just go with 2. Semicircle, straight line. That means they add up to 180. 180 minus 60 is 120. And so angle 4 must also be 120. All right, number 2. I see I'm dealing with a triangle, so already I have certain ideas going in my head that the 3 angles of a triangle add up to 180. I don't think I'm going to be able to use that because I don't have 2 of the angles. I notice this angle here, this 100-degree angle. What do we call that type of angle? It's called an exterior angle because it's outside of the triangle. And I'm looking for this question mark, which is an interior angle. So there's 2 ways I can find it. I'll show you both. The first way is we need to figure out this angle first. And it's easy to figure out because since this is 100, this angle and the one next to it, and I thought I switched the color of the pen, here we go. This angle and the one next to it are supplementary. They form a straight line, they form a semicircle. 180 minus 100 is 80. And now once I have this one, since I know 2 of the angles, I can figure out the third one. So that's one way to do it. The other way is to notice that this is an exterior angle, and we know that the exterior angle equals the sum of the 2 angles that are not touching it. So 100 equals 60 plus question mark, which means that the missing angle has to be 40 degrees. This is called angle U because this vertex is U. So angle U is 40 degrees. Alright, so that's where we're going to stop here. It was a long lesson. It was a lot packed in. The main thing that you need to take out of this lesson, I'm going to do the summary, even though we don't usually. Here are the main things you need to take out of this. That the three angles of a triangle, you can write it here, I'm not going to write it. The three angles of a triangle, the interior angles, add up to 180. You need that. Angles that form a straight line, or that semicircle, add up to 180. Angles that form an L add up to 90. And now the other key thing that you need to take away is this diagram. Whenever you get that diagram of intersecting lines, you need to be able to find all of the angles. So if they give you one of the angles, if they tell you this one is 135, you need to be able to find the other three angles. If you can do that, then you're good for this lesson. If you're okay with that, great. If I can give you a diagram of a triangle, tell you this angle is 60, this angle is 100, and I want to know this one and this one. If you can find those, great, you're ready for the next lesson. If not, then you should be reaching out. You should be asking questions in the live sessions, in the synchronous sections. You should be going on Google and YouTube and maybe finding some other videos on this, just some extra practice. But that's what you need to take out of this. This diagram, where you find the missing angles, and triangle angles, where you're finding all the missing angles. Hope everyone's doing well. See you in the next video.